Hi guys, so we are moving in from slope-intercept form into word problems that we have to disseminate what's happening in the word problem, build our equation, and then be able to use that equation in slope-intercept form to find a missing value that is asked for in our prompt. Two new learning standards here. Our learning target will be, I'll be able to interpret the rate of change, which is another word for slope, and the initial value, which in word problems represents our y-intercept, where the amount is starting at time 0. So we call that an initial value. You'll be able to pull those out of the word problem and be able to create a equation in slope-intercept form to represent it. And there's a learning standard, which is 8th grade functions, standard 4. And we're looking at the end of that standard where you can see the words interpreting situations and modeling those with equations. So let's get into this now. As you can see here, we use our 4 steps of problem solving. We're going to define, which is our let statement. We're going to say let X represent and let Y represent. We'll always have 2. We will have one variable representing the input values and one variable representing the output values. That's your X and your Y, or your domain and range. Then we're going to build that equation and we're going to represent it in slope-intercept form. And to build that equation, we need to identify the rate of change and the initial value from the word problem. Then we're going to use that equation and we are going to solve for the missing value that the prompt asks for, and then we are going to answer that question from the prompt in a complete sentence. And we're going to make sure that we reread that prompt in order to answer the question that's asked, not the one that we think might be the answer. So let's get into this. So number 1, excuse me, suppose that the water level of a river is 34 feet and that it is receding at a rate of 1/2 foot per day. Our question is, in how many days will the water level be at 26 feet? So here's our define. We're going to start it with let, and there should be 2 things that we're talking about. In this case, we're talking about the water level of this river, and we're talking about in how many days. So, and we have, and the number of days. So those are the 2 variables we're going to do, and we need to make sure we have a letter. So I'm going to use W to represent the water level, and I'm going to use, let's say, D to represent the number of days. So there's my 2, and I'll space this out so that you can see. So let W be the water level and D be the number of days. Those are the 2 values that I'm having. The water value, our water level, depends on the number of days. So I know that the water level is going to be my dependent variable. It depends on the days. So that's really going to represent that Y inside my equation, where normal, my dependent variable is shown. And then the number of days is my independent. Remember, any unit of measure dealing with time is our independent variable. Our independent variable is something something that we can't control. So that's always that time. So there's my define. That's my first step. Now I'm going to build. So from that, I know the Y and the X. I need to figure out the M, which is our slope. And I can see in here it says receding at a rate of 1/2 foot per day. Receding is a word that implies subtraction. It's losing this water level. So I know that the rate of change is losing, so I know it's going to be a negative, and I'm going to change that decimal into a fraction. If you'd like to keep it in a decimal, you're more than welcome to use that 5/10. And I need to know my B. Now my B value is the initial value, in this case, of my water level. So initially, this river is starting at 34 feet. So those are my 2 values, and now I have to put everything together. I have to put my dependent and my independent letters in with my values for my M and my B. So we should know that our equation should be in the form Y equals mx plus b, and I usually just write that out so that I'm making sure that I'm following with this. So my Y is now W, and my M is my -1/2. My X is my D, number of days, and my B value is plus 34. So it's the water level is equal to a receding rate of a half a foot per day, and the water level is starting at 34. So I'm going to use that equation in my solving. So there's that equation that I'm going to use, and I'm going to find my unknown. So my question is, in how many days will the water level be 26? So my D in this case, every time you do a space, it capitalizes it. So my D is my unknown in how many days, but they gave me my W, which is my 26. So how many days will be at 26? So what I need to do is take that equation that I created in my build, and I have to replace the W with 26 and solve for D. Okay, so there's my substitution. So if I have to write my steps down, here's my substitution. And then my next step is going to be subtract 34 from both sides. Let me just do another space there for you so you can see. So I'm going to subtract 34 from both sides of my equation, and hopefully you remember that you're using the subtraction property of equality to do that. And then my answer turns out to be here would be -8 is equal to, and I still have my coefficient and my variable term. So remember, if my coefficient is a fraction, I need to multiply both sides by the reciprocal, and the reciprocal of a half is -2. So I'm going to multiply the left and the right side by -2. And what operation allows me to do that? Multiplication property of equality. Remember, inverse operations we use. So therefore, I can see that 16 is equal to D. And I'm just going to take my space and line up those equal points. So I can tell that what I just discovered is after 16 days, my water level will be at 26. So then I'm going to come over to my answer and say, after 16 days, the water level of the river, will be at 26 feet. And there you go. That's the full 4 steps to problem solving. I'll have one additional video if you would like to watch number 4 or slide 4, which is problem number 2. You can watch the next video. Hopefully that helps on how do we set up the 4 steps to problem solving.